Hello everyone, I hope you're having a great day. Today is going to be the start of a new segment I'm going to call Fundamentals Friday. The intent behind this video series is to educate and understand basic programming fundamentals with industrial programming and PLCs. Um, so essentially any small or useful feature, whether it be uh, small features or even some more complex uh, concepts. We will touch on how it works in a fundamental sense, and in other videos we'll use it in a practical sense where we'll actually go into a real-world example of that kind of uh, use case. In the video today, we're going to be taking a look at tags and data types. Now, it is a fairly simple concept and fairly basic, but for people who either don't have any experience using tag-based programs or familiar with data types, this could be a very good video. It could help to introduce you to more advanced programming software that uses tags as opposed to addresses, or that use uh, advanced data types that are not common in other forms of programming software. This could be a very useful feature, a very useful resource for anyone who's interested in learning that. So if you're interested in learning, or maybe you might learn something new, please follow along and we'll get started. Alright, so over here, as you can see, throughout this video, I'm going to be using RSLogix 5000 version 32 for those of you who want to follow along with me. And we are going to be using a Compactlogix 1769 L24ER processor module. This module has built-in physical I/O, and I have some other devices attached to it as well, including an HMI. Now we'll get into the physical hardware later on, but for the sake of this fundamentals video, we're mostly going to learn about the tags and data type concepts. So as you can see, this program is currently running. That's not really a big issue. You can add tags, remove tags, or make changes to tags in a live program. Little bit finicky sometimes, but usually, especially in the case of a running piece of equipment, most of the time a programmer is going to find themselves adding and removing tags on a live program. It's sometimes very taxing to take the program down to do a simple download. In this case, it really wouldn't make much of a difference. This is my own personal test bench, but your situation may be different. So most of the time during this video series, and most videos I do in the future, are going to consist of me making changes online, mostly to demonstrate to the viewers how you can do that if they're not already familiar of that process. And if we need to, obviously there are certain situations where downloading is necessary, but if at all possible, it's always good to try and do things while the system's still active and do the changes online. Anyway, enough of that. In RSLogix 5000, you have a couple different areas of interest, and I won't cover this too much in this video, but just a quick synapse of where things are and where we're going to be going. So on the left-hand corner, you have your configuration tree, and this is where all of your folders and files for all of your different elements and programs, data types, and equipment, or your I/O, is contained. For today's video, we're going to be taking a look at tags and data types, as I mentioned. Now, there's many different ways to create tags, but one way that I prefer to do it is to create them within the tag database. and you'll find yourself in here quite often. Now, there's two types of databases for your tags. So you have, by default, you always have this first one called controller tags. Controller tags essentially is global tags. You can think of tags here as being globally accessible to everything in the program, including I/O and things like HMIs. Anything that you need to be able to be seen outside of the program or within the program in different areas should be in the controller tags database. Also, you'll see that I have different programs, and we'll get into this concept a little bit later, but each of the programs will come with one tag database. Now, these tag databases within the individual programs can only be utilized in that specific program. So let's say I want to make a tag for this routine here, and I add it here to the program tags for this program. I can use that tag in any one of these routines. However, I cannot use that tag if I wanted to use it here in I/O verification, for example. So that's what I mean by local or global tags. Typically, it's better, your results may vary, but it's usually better to just generate all of your tags in the controller tags database. And there's many different reasons why you would want to do this, but the main reason is you may not at the early stages know where the tags that you create are going to be used. You may make a tag for a specific routine and later on realize I want to utilize that tag somewhere else, and it's in a completely different part of the program that couldn't be accessed by that program tags database. Well, in that case, you would need to move it to the controller tags database. And I've done this myself, where I've created it in one and then I wanted to use it in another and I couldn't. I had to move it. So it just saves you a lot of headache if you go ahead and just make them in the controller tags database. Well, anyway, so that's where we're going to be focusing on today. Both the controller tags database and the program tags database are going to appear the same. So anyway, when you open it up, now I've already got some stuff in this program, but by default, you are going to have certain tags available all the time. So if you've got a pre-configured processor, as I do here, you're always going to have your physical and remote I/O, or your local and remote I/O, once you've generated that in your I/O tree. So let's say, like when I open this program for the first time, if I create a new one, the first thing I'm going to get are these three, which are my local tags. And this comes from the understanding of what type of processor I'm using. As I had mentioned earlier, this processor does contain physical inputs and outputs. Specifically, it has 16 digital inputs and 16 digital outputs. Different models may consist of different types of inputs and outputs, but the fact of the matter remains, you will still get a tag for all of these regardless. And in this particular application, I also have a remote rack, and that's this one down here, the AENet module. It's also referred to as point.io module by the manufacturer, and it's got 4 cards in addition to the module itself, and they also get a tag associated with them by default when you create the module. These are what are known as your addresses to your physical I/O. So for example, each of the remote racks consists of 8 or 2 input cards with 8 points each, so a total of 16 inputs. And then I have 2 8-point output cards, which makes a total of 16 outputs. So if you expand this branch, you'll see all 8 of those inputs for this slot 2. So what is a tag? Well, as we've already established, these that come with the program, or that come with the tag database when you first open it, are your physical and even virtual addresses. So addresses essentially tell the processor where the specific input or output is that you want to monitor. Tags are essentially a name that you can assign that particular physical or virtual point in memory. So those of you who have worked with industrial controls before may be familiar with addresses. Everything in the program has an address. The only real difference between an address in other forms of programming software and a tag in this particular application is the fact that the tag can be whatever you want it to be. It can be named something that makes sense to you as a human rather than a string of numbers and letters, which is common with standard addressing based programs. Another advantage to tag-based programs is that because it's created within the program and it's part of the fundamental structure of the program, that name remains with the processor's memory. So if you've ever uploaded a program from an existing processor and it was an address-based program, you don't have any comments or names for any of those elements within the program. They're simply just the virtual or the memory address location. You know, you can still troubleshoot the program just fine, but it's harder to understand the theory behind what's going on in the program if there's no data to go with it. There's no reference that you understand as a person. So tags give you that advantage. So let's create a tag. So whether you're online or offline, in order to create a tag with Studio 5000, we need to click this Edit Tags tab. This puts us into a edit mode of the tag database. And it always goes from or starts with new tags at the bottom of the list. So whenever you want to create a new tag, it's always going to have this empty field at the bottom. So we have a couple different columns to keep in mind. We have the name. The name is your tag name. This, like I said, can be anything that you want it to be, but there are exceptions as far as character limitations. For example, standard names cannot consist of periods or standard spaces. Now you can have spaces in your name, but it's common that you're going to end up with an underscore in the name if you wanted to add a space. There's also a limitation of how many characters you can have per name. So I can't just write a whole sentence. Let's say, for example, a test button, if I can spell today. Test button would be a word. We can use that, but just to demonstrate, I couldn't say like test button for start So there's the limit. Obviously, this is a very unrealistic situation, but just to demonstrate, I'm currently out of character space. So just to demonstrate, most of the time in a practical scenario, because of your character limitation, it's common to want to abbreviate or shorthand the words used in your tag. Some people, programmers, will remove vowels, for example. So, like test button, for example, might become TST BTTN. So we got rid of the vowels. Or whatever you want to do. Some programmers, as something that I commonly do, will usually have some kind of initial abbreviation to dictate what the tag is. So one method I've used in the past was DO for digital output, or you could even just dig out. Now, I said I sometimes remove vowels. You don't necessarily have to remove all vowels if you don't want to. Sometimes I toggle between those. It just depends on your particular situation. But short words like out, on, off, things like that, I keep those as standard with their all their letters, and do not abbreviate them because they're shorthand or non-abbreviated or abbreviated form wouldn't make sense. If I took out all the vowels exclusively, like the word on, it would just be the letter N. So that makes no sense, obviously. So just as an example. So we'll go back and make our test button. Because this is a very short amount of characters, I'm not really too concerned about abbreviating this, but either way. So, as I said, you have multiple different columns. The next column is your alias. So, as I had referred, you can make tags reference to particular address locations because as far as your physical inputs and outputs are concerned, they still have an address associated with them. So what an alias is essentially the name is referencing a particular address location, meaning you're giving a name or an alias to a physical address. Now, if the tag doesn't have an actual input or output associated with it, you don't have to assign an alias. And for reasons we'll get into later, it's common to not even assign aliases to physical input and output bits. And we'll get into the reasoning for that later on, but for the sake of this project, I will create a tag with an alias just to show you. So when you want to give a tag an alias, you don't necessarily have to give the alias or have to use an actual address as the alias. You can actually assign an alternate tag to a new tag as an alias. It's not common to do that. In fact, I don't think I've ever really seen anyone do that before, but you can if you wanted to. But most common use case of aliases is going to be your physical address. So let's say we want to attach this to the slot for, let's do slot 1 because it's actually an input. And we'll do it to input 0 on slot 1 of the remote module. So now test button is associated with that tag. The next column that you will commonly use is the data type column, and we will get more into later in this video what a data type is and the different types of data types you will commonly see, but for the sake of this video, we'll just consider it to be whatever the default is. So when you give a tag an alias, if the alias is just a single bit, for example, like in this case, it automatically assigns a data type for you, in this case a bool. Bool is an abbreviation for the word boolean, and that just refers to the fact that it's a single bit, so it's either 1 or 0. And like I said, we'll get more into what that is later, but let's go on to our next column. So the next column of interest is the description. Now, you do not have to give a description for your tags if you don't want to, but in my experience, comments, descriptions make coming behind yourself a lot easier. I've done it in the past where I've written an entire program for a machine, years ago, and didn't comment on any of my tags or didn't provide a description. I even have entire elements of logic that consist of no comments whatsoever. And I come back behind myself and I kick myself because even though I wrote the program, I understand what's going on logically, but I don't understand the theory behind what I was trying to do anymore. Like my thought process just isn't there anymore. So, like I said, you don't have to comment and give descriptions, but think of it as you looking at it from years ahead, especially as you get more involved and more advanced in your programming techniques. As your programming evolves, you will begin to kick yourself for not having good descriptions or comments in your programs. So it's just a common thing, and for other types of programming situations, regardless of whether you know what's going on or not, it's always a good practice to comment and describe what you're doing, even if you're just talking to yourself. It can't hurt, and it just means you won't get lost in your own programs in the future. But anyway, so we'll add a description. So all right. So with descriptions, you can have as many characters as you want, but you'll see later that it does kind of matter how much of a description you give yourself. Really, what I like to do is just give a general, clearer explanation to what the tag is. So while I may have abbreviated in the tag name, in the tag description, I can unabbreviate the text and describe more on what it's doing. Not be very specific on exactly what this specific bit does or is for, but just a general synopsis of what the tag is. What is this element in the program? So the next column you'll see is external access. What external access allows you to do is dictate whether a device can read or read and write to that specific tag, or neither. So say, for example, you have another processor connected to your program, and you only want it to be able to have access to certain tags to read and write, but the rest of the tags you want to keep as read-only. Basically what read-only means is that the other processor can only see what's in memory but can't change it. Whereas if it's read/write, then the external device can also make changes to that particular location in memory. The next value, or the next column you'll often see, is constant. So let's say, for example, you have a particular memory location, let's say a value. You don't want the program to change that value. let's say it's a set point for a timer. You can create a parameter in your tag database which is a constant. If the constant is selected, then the program itself cannot change that tag value, even though it is a tag, even if it's accessible to other programs, it cannot be changed without modifying the program. So that's a pretty useful feature, especially for parameter settings or what have you. And then the final column is the style. Now, style really doesn't offer you anything other than the ability to change how you view the tag. It also changes how the tag is viewed in the program. So let's say, for example, you have a string of bits that is contained in an integer value. But within the program, you're modifying individual bits. You can make it where the style is shown as binary. That means that when you see it in the program, you only see a string of ones and zeros rather than the integer value of the number. So rather than seeing the number 255, you'll just see a whole lot of ones. So that's all that means. So once you've created your tag, you can simply just close out of the tag database, or you can press monitor tags, which returns you back to the read-only form of the tag database. And usually when you create a new tag, your tags always show up at the bottom, the new ones that you've created. Typically, the tag database is alphabetically arranged. However, as you create new tags, at least in Studio 5000, every time you create a new tag, they always show up at the bottom, even if you create the tag within the program itself. So, but once you close out of the program and come back into it, all the tags will be alphabetically arranged again. There's also a way to automatically do that by forcing the order up here at the top of the column. You can also change it to, instead of an ascending order, or instead of a descending order, excuse me, you can change it to an ascending order. So, as I mentioned, this is one way to create a tag. There's also another way to create new tags. So we'll go back to our routine, and let's say I want to add a tag to this branch. So we'll go and we'll edit this rung, and I'll create a new tag. Fun fact, if you ever want to go in and edit a rung in Logic while you're online, there's two ways to enter into an edit mode. One common way is to just double click here on the side panel of your rung. That's one way. What I find to be most useful, or the way that I like to do it, is the shorthand way, or a hotkeys form. So the hotkey to edit a rung is Control-Shift-S. This enters the rung into an edit mode, but as you can see, it's also pre-selected the element that I last had selected, excuse me. So let's say you had a fairly long branch of logic. If you do it this way, you'll stay exactly where you were when you were looking at the element. It may shift the view, but the element that you had selected will still be in view on the screen. Whereas if you go back to the top of the rung and double click at the side, you end up at the top of the rung and you have to find where you are in that branch. In this case, it's a small branch of logic, but the truth remains the same regardless of where you're using it. So anyway, back to the show. We're going to add an output. So in order to create a new tag, in this case we're going to add a new output, you can right-click in the program or within the routine and select New Tag. Whenever you do this, make sure that you are right-clicking on this question mark. Whenever you see a question mark or whenever the branches show up as red, this is an indication that the tag or a tag on this branch or this rung is undefined. But you can't click the element itself and right-click to change or create a tag. You have to click the question mark and select New Tag. Now, if it was a situation where you had already created the tag like we had done earlier, an easy way to get into that is to just double-click, and it will bring this drop-down menu where you can then find your tag. Just like in the tag database, as I mentioned earlier, it's alphabetically ordered. But you can also search for the tag that you created. So like if we wanted to use that test button, then we can just select it. But we won't do that. We're going to create a new tag. So as I said, right-click on the question mark and select New Tag. You will get this dialog box, which will be where you create the new tag. So as we had in the tag database, you have boxes for all of the different objects that you could edit earlier. So at the top, as you had before, you have the name. Again, just like in the tag database, the name can be whatever you want. There are character limitations, and there's a limit of how many characters you can have. In this case, we'll just name it Test Light. Okay, and we will give it a description. This is a test. Okay. Again, you can assign an alias if you wanted to, but in order to do this, you do need to, within this dialog box, you actually need to tell the controller you're using an alias. If you didn't want to use an alias, let's say it's a base essentially means that it's a tag that's used within memory but doesn't actually go outside of the controller. It's not associated with another tag. It's not an alias for anything. It's simply just a tag by itself. For the sake of this experiment, we will consider it an alias, just like we did with the other tag. If we sign it as an alias, we now need to give it an address for that alias. So as we did with the other one, we'll put it on that remote rack, but we'll put it on one of its outputs. So let's go with card 3, because I know that is an output. And we'll go with output 0. Actually, I think 0 is being used. We'll just use 2. It doesn't really matter which one you use as long as it's consistent. Typically, you want to follow whatever's in your electrical prints, and whoever's dictated that if it's an actual practical situation. But for the sake of this, it really doesn't matter where we put it. Just like in the other example, you have a data type. But since we've associated this tag with an alias, which is already a bool, it automatically populates this field with the word bool. Earlier we could have changed it before we assign it to this alias, but now we cannot. Anyway, so we don't have the ability to select parameter connection. This will be a topic we'll discuss later. Scope. So when you create a tag here, it doesn't really know where you want the tag to exist. As I had mentioned earlier, you have multiple different locations tags can exist. So by default, it will go in, well, traditionally, when you first use Logix, I found that the first place it goes is the program tags of the particular program you're in. But once you change it, it tends to stay with whatever you changed it to the last time. In our case, it's pre-selected to use the controller tags library, which is what we want. But if you wanted to change it to a particular program database, you can do that here and select whichever one you want. Just make sure that you create it within the program that you're using. Here you can make it create the tag in wherever you want. But if I create it in a program that doesn't or is not the one that I'm currently working in, then I won't see the tag and it'll still show up as undefined. Even though the tag does exist, it doesn't exist within this specific program. So I can't see it, I can't access it, so as far as the controller is concerned, it's undefined. Another example of why I recommend using it in using the controller tags database, because it pretty much reduces any confusion. Every tag you create can be accessed anywhere. But either way, again, you have the external access and the style. As we described earlier, same concept here. Once you're done creating the tag, you create the tag or click Create Tag. So once you do that, this is what it ends up looking like. So you have your description that shows up at the top, your tag name, which shows up next, and because we gave this tag an alias, you have the alias name just below that, or the alias address, I should say. And then obviously at the bottom, the element type. Now that we have that finished, we can push this change to the controller, because right now it's still a modification that doesn't exist in the processor yet. So to do that, we finalize the edit and say yes. So now that we've pushed the edit, as you can see, the element is blinking at the same rate as the strobe bit that was already there. Fairly straightforward. Okay, so the next topic we're going to discuss is data types. So I've kind of expressed that a couple times, mentioned that phrase many times throughout the recording. So what is a data type? So what is a data type? Well, in layman's terms, the most simplest explanation is it's essentially the type of data that you're using for a specific tag. So as I mentioned several times already, you have Boolean, which is one of them, but you also have many other types of data types available to you in the controller as or by default. So if you were ever curious to know what specific data types are available for your particular processor, one good reference or good place to go look is predefined. Predefined is going to show you everything that comes with your specific application at that time. And predefined tag or predefined data types there's a folder for that in both 5000 and 500 and any programming software. It's going to have somewhere where it defines existing data types that you already possess. In Studio 5000, it's under the predefined folder, and if sometimes this folder is collapsed under assets, so sometimes when you first open the software, the assets folder will be completely collapsed. So in order to see your data types, you just have to expand that folder, and it will be under data types and predefined. You have many different types of folders for data types in addition to the predefined. So we'll go over those real quick. So user-defined are data types that you as the programmer can create. Now we won't get too deep into that. In a future video I'm going to do a video on explaining creating user-defined data types and where to use them and the benefits that they offer. but for this video I'm just going to kind of gloss over it. But essentially, a user-defined data type is one that you create. Um, strings are characters. So strings by themselves is already a data type, but sometimes, let's say you wanted to have a situation where you had a string of multiple characters. Let's say it's an alarm message or the name of an object in the program, and you wanted to put that name on the HMI, for example. It's going to consist of more than one character to do that. You may need a string of, let's say, 10 characters or 40 characters or whatever. So one data type you may often have to create is character strings. So all you do is tell the controller, hey, I want to make a tag with, or I want to have a data type that allows me to put 40 characters in a memory location. So that's all that is. So you can make those. The next folder is add-on. So another thing we'll discuss in a future video is the ability to create your own blocks of logic. And these are referred to in Studio 5000 as add-on instructions. So whenever you create an add-on instruction, it's going to consist of its own data type, whatever you define in the program. So that will have its own data type associated with it. The next folder, as we already discussed, is predefined. Predefined, like I said before, is what comes in the program by default. It's as soon as you open the program, that's what's available. New application, brand new program, never been written, that's going to be predefined. You're not going to have anything. And then you have module defined. So after you create the objects in your I/O tree, that is what ends up being populated here. So as you see at the top of our program tags list, you have like these I/O nodes and this local module. Those have special data types for them. Right here, this AB, comma 1734, for example. That's our point I/O module's data type. And if we open that branch, you can see those same data types available. So again, all that is just a reference for the processor. When you tell the program that you're using a specific module, every module you add, every new module you add is going to get its own data type if one exists. And typically all modules are going to have an existing data type unless you are creating a new module from scratch. But even that will have its own data type. But the one we're going to focus on most today is going to be within the predefined. We'll get into the other types of data types in the future, but for the sake of this video and for the majority of future videos, most of our tags are going to relate back to the predefined tags that are available. So what tags do you typically get? Well, as you can see, you get a very long list of predefined data types. And again, we're not going to get into all of these in this video. I'm only going to really hit on the most common, frequently used data types that you'll find used in programming. So, so the first one, as we've already discussed many times, is the Boolean. Again, that's just a single bit. It's just a 1 or a 0. But what other kinds of data may you want to utilize? Well, let's say, for example, you wanted to have a value, whether it's an analog value coming back from a card, or it's a set point for a timer, a parameter, whatever you may want, a number. There's two types of numbers that you'll commonly use in Logix Designer. Those two are floating numbers and integers. So what are the difference between those? Well, a floating number, or in 5000 it's referred to as a real number, can be any number including fractions of a number. So it would consist of whole numbers as well as decimals. Anything below 0, above 0, fractions, whatever. As the name suggests, it's real numbers. You'll typically see real numbers used with physical analog inputs and outputs. So let's say you have an analog sensor input. Let's say like it's a temperature reading. So you could set it up where you only see the first two major numbers, so the whole number digit. But in most cases, you're going to want to know at least 2 decimal places. So instead of just knowing that it's 32 degrees Fahrenheit, you may want to know it's 32.58 degrees Fahrenheit, for example. So that's a real number. The other type of number is an integer. Now an integer can only ever be a whole number. Integers cannot represent fractions or decimal places. Now there's different types of integers available in the Studio 5000. So what different types are these? So if any of you have worked with RSLogix 500, you may be familiar with the term int to describe an integer. And that is still available in 5000. Now, just like in 500, an integer consists of 16 bits, or 2 bytes. So, as I mentioned before, they can only be whole numbers. They can go plus or minus, but it can only be, 1, 2, 3, 4, whole numbers up to the maximum number of bits. So for an integer that consists of 16 bits, that would be from 32,762 or 7, whatever it is, to minus 32,000, whatever. One way that you could figure out what that is you can open up your calculator, and most of the time they have this program mode. So if you want to know what 16 bits can count to, or whatever, you can say that it's give me 16 bits. That's 8. Oops. And we can change that to a decimal. As I said, it was from 0 to positive, so it's actually a division of that number, because 65,535 is the maximum number you could count if it never went negative, but because most of the time integers do consider the most significant bit, or the very first bit, to be whether or not the value is positive or negative, you actually don't end up with that value. You end up with, so rather than actually having all 16 bits, you really have 15 bits, and the last bit would be your sign. And so that ends up being 32,767. So with an integer value that can go plus or minus, you would have from plus 32,767 to minus 32,767. And that would be your range. But you have more than just one type of integer data type. In fact, there's another one here on the screen. So there are 4 or 5 different integers that I know off the top of my head. So integer is one, but you also have lint, you have sint right here, and then you have dint right here. Now, by default, let's say I wanted to go back and create another tag like I did earlier. I don't know if you guys noticed it, but as I started creating the tag, so when I create the new tag, it automatically gives me a default data type. And in 5000, the default data type that I often will get is a dint. So what's a dint? So the first character describes basically how many integers or how many words or how large the word is. So a dint is a double integer. So one integer is 16 bits, so a double integer is going to consist of 32 bits. And then you have other significations. So sint, as I showed earlier, I sometimes refer to as a small int. Sometimes I've heard it called single integer. Either way, it is 1 byte or 8 bits. And then lint, like we saw earlier, is long int. So that consists of 64 bits. So depending on your situation, you may need a specific number of bits for your particular application. And it really boils down to how large of a number are you trying to count to? What is the device you're talking to? Is it limited to 8 bits, 16 bits, 32 bits? So your particular use case scenario is going to be dependent on what limitation you have on the device you're communicating with. But you do have many different variations available to you for your integers. Another common type of data type that you will see used very often are timers and counters. So, as the name suggests, it's timers and counters. So, if you want to make a timer on, a timer off, or some kind of other timer-based delay, you would need to use a timer data type. And counters work very similar. They have similar data type bits, but it's for counters, so counting up, counting down, or just keeping track of a value. So basically any element within this tab, when you're adding elements, that's going to be, or those tags are going to fall within this particular signification. While that's not a comprehensive list, and that's not all data types that you'll use, at least for the sake of this video, that's the ones that you will see used most often. Pretty much everything you're going to focus on, most programs you're going to write, are going to utilize all of those data types at the very least. You may use the other data types too, but more often than not, those are the ones you're mostly going to be focused with during your programming experience. The other data types we will slowly get into also, but again, those will be topics for future videos. Are you still with me? So anyway, guys, I appreciate you guys for sticking around, for those of you who are still sticking around. If you like what you see, maybe consider liking and subscribing to the video. Or, make suggestions for future videos if there's something specific that you want to see or want me to explain more in future videos. Please leave a comment down below. Let me know what you think, or if there's anything you want me to work on or do better at. Any suggestion, any comment is great. Well, anyway, like I said, thank you for watching, and look forward to seeing you again next time. Take care.